Okay. So, well, very briefly, we are going to go over some of the things we discussed, yesterday, and then see. Hope no one saw that. I don't know how that thing got to my. Oh, I see. I know how it got there. Okay. Okay. I think this is what we're using. Okay. So we're just going to briefly go over some of the things we discussed last week, and then we kick off from there to go on, right? Then after that, I'll show you a few things and a few resources you can use, especially those who are well the interview, their design interviews and other interviews in a couple of time. Also, one thing we are working on right now is to create sample answers to sample interview questions, right? So that people can read through. I plan to roll out one, maybe got an end of today or early God willing next week. Okay, so let's see what we can do for today. Okay, and if you have any questions or something, do well to just alert us and then we shall see. Okay, so we are starting. I don't know if this is clear. Let's see if we can change the color. Okay, I think green is a bit distinct. Okay, let's use the tail one. Looks cool. Okay, right, good stuff. All right, so let's go ahead. So, yeah, so we were going over databases, right? And we said databases simply allow you to store and retrieve data, right? And then we said we can categorize databases into two main kinds currently. We have the relational database and the non-relational databases, right? We said the relational database organizes data in the form of tables, right? And this is an example, right? Where we have a table, yeah, this is a table, and each row in the table, right, we call it a record, right? So the record simply represents the information we are storing. And the record is kind of in the form of a tuple, right? Those who know Python tuples. So tuples are simply, like something like this. It's just a tuple, right? So the first item here is basically for like the first entry. Let's say the name. Then this is like the number. This is like, the phone number and so on and so forth, right? So we just put these tuples, as records. That's like the information for every single row. And then we went over non-relational databases, and then they did not store their data necessarily in the form of tables, but different forms. So those forms could be key value stores. We have columnar, we have documents, some are even graphs, some store their data in the form of graphs, right? Then we said for relational databases, one we also call them, one main way to communicate with them is using the SQL query language, right? SQL. So SQL is the language that allows us to communicate with relational databases, right? So just to give you a brief history. So, relational databases have been in use for a very long time, but then, it has a couple of limitations. So, these group of people come up, they're like, well, we just want to do something extra, something else, right? We can talk about the limitations later. And then, they create these other versions of databases that does not necessarily use SQL, right? And that is a NoSQL database. So NoSQL is not necessarily NoSQL. It means not only SQL, right? So NoSQL here, it's actually like an abbreviation for this is not, right, and this O is only, right, not only SQL. That is like, hey, SQL is in use, right? And I think there was actually somebody who created a tweet on Twitter, and then that was the hashtag or something. Then it got adopted, and we just use like no SQL, no SQL. So it's just like them telling, hey, this you can also create databases that you can utilize and manipulate without using just SQL. So that's why we got the NoSQL databases. They went over a couple of relational or SQL databases like Postgres, MySQL, SQLite, and so on and so forth. Then we considered one version of a NoSQL database like MongoDB that stores data in the form of documents, right, or JSON format. So that's how you see the data. So this is like this is a JSON, right? A JSON. Then like the key is the name. Then the value is Kofi, age 24, and so on and so forth, right? So one thing, but then we said under the hood, it doesn't. It's still in the form of something called BSON. That's just an extra thing you can decide to know, right? Then we went through query language, the SQL query language. Then we went through some basic SQL, right? Like you can create a table, you can insert a record, you can update a record, you can join tables, and so on and so forth, right? Then we just went to SQL Alchemy. That's what, like, hey, sometimes people don't really want to write raw SQL code. Instead, what they do is that they learn SQL Alchemy. What SQL Alchemy allows you to do is that you write your code in the normal language, like Python or Java or whatever it is, and then another code is going to convert it into SQL for you, right, to manipulate your database. That's what SQL Alchemy does. It's an ORM, right? It's just object relational mapping, right? And then we talked about joining, right? Joining is something typically used in relational databases, right? So if you have this table, I have a table for users, I have a table for comments, right? And let's assume you have this question, right? I want to see all the comments made by some user, right? I want to see all the comments made by some user. So as you can see, users already, this is the users table, this is a comments table. There are two distinct tables, right? There are two distinct tables, and that's how it works, right? But then, so if I want to see all the comments made by some user, if you think about it in terms of programming, it's simply as, hey, just give me that user's ID, right? So I just get that user's ID, right? So let's say it's user 2, I just get user 2's ID. Then I'll just come here, right? And then I'll use like a for loop or something. Then I'll loop through all these things, right? I'll loop through all these comments and see if the author ID is 2, then maybe I'll append, that comment, right? That's thinking about it in terms of code, right? But SQL gives you a way to do that by what you call joining. So what joining does is that it can take two tables, follow me carefully. So here, users and comments, then it will join those tables. So how does it join them, right? It joins them by using what you call the join condition, right? Basically the join column. On what column should I join these tables, right? So if I join, these two tables on this first column for users and this second column for author ID, what is going to happen is that it's going to, let's try to sketch that. I don't know if we had a sketch of that. Let's just write that here and let me just show you how it works. Joining is super powerful and it's so important. And it's one thing that one advantage that relational database have over, non-relational databases, right? Joining. So if you have if you have a system you are building, right, that's going to make good use of these things. Usually we use the relational database because of joining. Joining is also very expensive, as we will see later. So let's see how that is going to look like. So if I wanted to join these two tables, right? So what I want to join these two tables, right? Because I want to see, hey, if I give a certain user, I want to see all the comments made by that user, right? And that is joining. So if I join on UID, right? So let's just see here. The join column is UID, right? So let's just call it users.uid. That is, go to the users table and take the UID column, right? The column called UID. So this is the users table, the UID column, right? Should be equal to comments dot author ID. Let's call it AID. Let's just call it AID. Right? So this is what that is going to do. So when I specify my join condition like this, what it's going to do is that it's going to take, if I have, let's say, UID, right? So let's see how the sample output table will look like. And this is the query. If you want to look at the query, I can write the query somewhere here. Select, name, this is just what I want, from users, join comments on this. If we've not done SQL, this will look a bit weird, but it's just very simple. That's like, hey, select whatever thing you want. I just want the name and the comments from, right? From this, right? From this. So this is like from this table, right? And this, how do I get, what is this table? This table is what we are constructing right now. So just follow me, right? So select the name and the comments from this table, right? And let's look at that table. So that table is going to look something like this. So I'm going to have the UID, then I'm going to have the name, then I'm going to have the author ID. Let's just call it AID. Then I'm going to have the comments, right? Comments. So if I have UID of 2, right? If I have a UID of 2, I'm just trying to expand everything to make it clear. If I have a UID of 2, right? The name is going to be A, right? Think of it as a nested for loop, right? Of A, then let me just bring this one. Sorry, let me just make it clearer by just bringing the AUID close to it. AUID, then name, and then comments. Let's call it CMT. So UID2, right? Author ID2, and the name is A, then it has a comment Q, right? Then UID2, does 2 has something else. I think 2 again. Then it has a 2, right? Then it has P. It's A again, has comments P, right? I'll explain this very briefly. Let's just, I think that's all. So what I just did here is, if I take this UID2, right? It can map with 2 of these, right? It can map with this and that, right? That's what it can map with, right? So this UID2 here, right, is the same as some 2 here, the same as some 2 here, right? So that's what I have here, right? So just like a for loop, right? If I take this, just use a for loop to go through, and if any of these things match it, you have that, right? And then we just match it here like this. So that's how joining works. So just think of joining as, kind of like taking 2 tables and then overlapping them, right? And you overlap them by specifying a join condition. So if I take 3, for instance, the same thing. If I take 3, when you join these tables, this 3 is going to map to this guy here, right? So if I want the comments made by user with ID2, is going to be P and Q, right? Because I can just see 2 here, right? Then to be P and Q very smoothly, right? Very smoothly. And if I want to see their name, I can easily find their name here, and so on and so forth. Let's move on. And then And then we talked about indexing, right? And I said indexing is something so important. Like nobody says they know database without knowing what indexing are, right? Indexing is super important. What is indexing? Indexing is just a way of, finding data faster, right, in your database. So for instance, assume you have like if you take like books, right? There's a page called indexes, right? Where you want to see, hey, where in this book, where does the word come appear, right? So usually it looks something like this. So like Amma, right? The index will tell you it's on page 1 and 3. Kofi is on page 2 and 7. Kwame is on page 18 and 12, right? And that is what indexing helps you with. It allows you to easily find information, right? So what we do is we index a column, right? So you may have your relational database like this, or you index, let's say, the name column. So if you think so, please pay attention. If you're doing an interview or something, right, a system design interview or something, and let's assume that there's some column that users will usually use, right? There's some column that will mainly be, let's say, it's a phone, it's a, what do you call it? A phone book, right? A phone book system. That's what you're designing, right? And usually what people do, they give you the name, then you give them the contact, right? That means you want to create an index on the name column, right? Because that's something people usually be accessing, people will be using, right? So if you be accessing some column very often, getting some data from a column very often, what is that you create an index on that column. What that simply does that it allows you to effectively retrieve data from that column. There are many types of indexing. Did we get there? I guess we didn't. Let's just talk about some of them very briefly. There's a couple of there are many algorithms to create indexes. Very popular ones include what you call the hash indexes. There's one called B-tree indexing. There's a couple of newer ones called gen indexing. Even B-tree, some even can use B plus trees. But the difference is very slight. No problem. Then we also have RAM indexing, but the others can do like what do you call it? There's this other one. Don't worry, it's even gone. All right. So let's just look at hash indexes very quickly. Maybe B trees. And yeah. So what hash indexes do is that, follow me carefully. Like you need to know how hash indexes work. Like you need to know it, right? So hash indexes is just like the same hashing you've been seeing in what do you call it? In Python and Java. It's literally the same thing, right? So let's look at what hash indexing, how it works. I'm going to show something called a log, right? I'm going to use so right now we've shown you how databases work, but somebody may be like, wait, how are databases, like how are they kind of, think of it as an abstraction, right? But how are they really implemented in the computer, right? Like how does it look like, right? So one way to think of how a database is implemented, like an actual database, think of Postgres or think of something, how it's implemented, or in other words, think of it as how a certain, how you can implement a certain thing that is able to store your data, right, and retrieve your data. How can we implement such a thing, right, in your computer? So I'm going to use the concept of a log. So follow me carefully. What a log does is very simple. Think of a log as a certain structure. Think of it as a text file, right, like as a file, that you can only append to. Right? So that's how the database we are implementing works. So a database allows us to implement to some file, right? So let's just think of two things. Let's say phone number, and then the name, right? Or maybe let's do it name, phone number, name. So we're actually designing a database right now. We're actually building our own database. Name, phone number. I'm gonna show you how hash indexing works. Name and phone number. So I'll be like, hey, name. So name is maybe Cornelius. My phone number is 6, right? Maybe Osei. Maybe the phone number is 4, right? Maybe Osu, the phone number is 3. Then maybe Kwame, the phone number is, let's say, 2, right? So this is how logs work. You can only append to a log. That's what a log means. When you see log, simply means, hey, we just append to you, right? So let's see how hash indexes work. So hash index, as I said, is just like the hash buckets you have been using, hash tables you have been using. So this log is going to be stored on your disk, right? Like your hard disk is going to be stored on your disk, right? But then if you want to create, the index, right? You want to create an index on this database, what we can do is that we can create an index data structure. That's basically a hash map. We're doing hash indexing now, so pay attention. So we can create that one in memory, right? So in memory, we're going to have, a hash map like this. And when we do, right, and we create the index on the name column, right? So index here, we create the index on the name column. So what I'm going to simply do is that I can simply, when I put like corn in my hash table, I just, add it to my hash map, and then maybe be like the value there is 6, right? Then maybe when I put aside, I'll store it also in my hash map as, let's say, 4, right? Then let's say I put aside again, I'm overriding the current value. I said a log, you can only append to it. So I'm like 12. So then it can, come here and then change it from 4 to 12, right? So this is just it. So right now we've actually implemented a database here, and we've actually created an index for it here, an index structure. That is the thing you are seeing here, right? So now if I come to read data, right, the data reading should be faster. That's what indexes help you with. They help you to read the data faster, right? Note that this is something you may not know, but please keep in mind, reading from memory is way faster than reading from disk. Memory is very fast, right? So if I try to access data from my database, assuming I want the phone number for Con now, right? Before I go to memory, that's going to take a lot of time. I'll quickly first go to before I go to disk, right? This takes a lot of time. I'll first go check, my memory, right? And inside my memory, I have my index structure, right? And I can simply find it, and then I'm done. So my reading is very fast now. This is a basic hash index, and that's how it works. That hey, you have the data on your disk, but you have created an index on it here, and then it makes your reading very fast, super fast, right? That is how hash indexing work. There can be variations of it, right? Right now we just used one log like this, so it made it very fast. Another way you can do it is something like, I think we actually illustrated that. This is one way you can also do it. So let's assume that it's not a log. Your data is not just any log, right? Maybe it's occupied, it's in pages like this, right? But this one is on disk. Please note that, as I said, going to disk takes time, is slower, right? It's slower. Memory is faster. Just put that in your head. Disk is slower, right? So in a hash index, now instead of maybe storing like maybe AMA, right, and be like AMA, the value is 5, what we can do is that we can actually, instead of 5, we can actually specify the page on which AMA is, right? So it can be like, hey, AMA is on page 1, right? So when I try to access AMA, I'll go to page 1, and then I'll scan until I find AMA, right? So hash indexing, the value can be the page number, it can be the value itself, all depends on the implementation, right? So that is one way hash indexes work. Very simple, right? Just like a hash map, how it works, right? So you don't have to jump to disk and then start scanning something, right? You don't have to. I mean, ideally you start from the back, right? You start from down, because I'll say this is the most recent value instead of this one, right? So log indexes, right? This one we just discussed, this basic one, is actually very much in use. There are a lot of database, search engines that actually use this log structure. And usually what happens is, you can see a couple of, inefficiencies with it, right? Like if you look carefully, for instance, like I know that I don't need this Osei again, right? Because I've given you a new value for Osei. So usually they do something called compaction, right? And what compaction does, we have compaction and merging. What it does is it kind of like breaks the log down, then just removes the once you don't need, then merges everything back. But just something to know, right? Then let's look at the other one, right? The other structure we can actually look at is the other indexing structure system we can look at is the B trees, right? Now how B trees work, before B trees we can even look at what's this? Look at the sorted string indexes, but let's just go to B trees. I think B trees have and B trees just like this guy. I can just tell the difference later on. So let's see how B trees work. B trees store your data, right, in a sorted order. And let's see how it stores it. So what it does is that, so let me just draw some structure here. It's a very quick structure here. And let me show you just how B trees indexing work. Okay, so let's assume that each of these guys is a page, right? Each of these is a page. Think of it as a text file, right? It's a page, right? And each page is like 4 kilobytes, right? So they have they have fixed size for B-tree indexing. Each page has a fixed size. Like think of it as how much data it can store. 4 kilobytes fixed, right? It's 4 kilobytes, like 4 kilobytes. So how it works is that it keeps the data in a sorted order, right? And there are many, tree, and this is actually a tree structure, by the way. It's a tree structure. So just we call it B tree. So yeah, it's a tree structure, right? And there are many, ways. Those of you who have done binary search trees and other trees, right? There are different types of tree structures you can use, right, to keep data in a sorted order as efficient as possible. One of those trees, what we call the red-black tree. We also have the AVL trees and so on and so forth. These special tree structures allows your tree to be complete. When we did heaps, we discussed what those things mean, right? Like we want the tree to have, we just want like, so something like this. Like we don't want an inefficient tree like this. We don't want this inefficient tree, right? We want to decrease the levels, as few as possible, so that we want to decrease the levels, so that here we just went 3, right? But if it's inefficient, it's going to be linear time, right? When we did binary search tree, right, we said it's good that the tree is balanced and also complete, right? We want a very balanced tree. And existing balanced trees, we know in computer science are like the red-black trees, AVL trees, and so on and so forth, right? So that is how the B trees work. So let's see how B trees works. It keeps the data in a sorted order. No binary search trees also in a sorted order, right? And so on and so forth. So let's see. So let's say I want to look for AMA. right? Okay, let's say I want to look for Amma, right? So one thing it can do is and let's use numbers now. I think numbers will make more sense. B trees. So let's use numbers now, right? So let's just say this is let me just create some slots here. Just follow me. It's very easy to understand how B trees work, right? How B trees work. So we are still on indexing, right? How to efficiently find information in a database without having to scan through all, the whole table or the whole database, right? And this is one structure, one method, B-tree indexing that they use. So what we can do here is that we can actually put, let's say, so 0, we're going to set boundaries in our table, right? Boundaries. So how this how boundaries are going to work. So let's say this is 10, this is 20, right? So, and let's say this is say 5, and this is say 7, right? Let's say, okay, let's just focus on this one. So let's assume I'm looking for the key. Please pay attention. I'm looking for the key, the value for key 8. So this is the key. The key is 6, and I want the value. This is what I'm looking for, right? So how the B trees, B plus trees work is that you give me the value, then they'll start from the root page. This is the roots page. Then it'll be like, okay, so this 6 is the value, right? But then this is 10, right? That means that 6 must be here. 6 must be somewhere here, right? And here, what we usually store here is what we call a reference. We store a reference here, a reference here. And the reference here just points to another table, right, that we have here. So I'm looking for 6, right? But then I come here and it's like 10 is here. That means that 6 should somewhere be here, right? You can use binary search to basically do this, right? So I'm like, okay, so I come to here and this is actually a reference to another table. And I come to this other table, right? And this is 5, right? This is the key for 5. So that means that 1 to 4 are here, right? This 1 to 4. Right, 1 to 4, I should maybe follow the reference here, right? But then this is 5, then this is 6, so this is also a reference. So let's just put a reference here. This is a reference to, this is a reference. Okay, so I'm still looking for 6. This is what we're looking for, right? We're looking for 6. So I was here, then I came down here, right? And then I'm down here, and then I'm like, okay, this is 5, right? And then this is 7. That means 6 must be somewhere down here. But oops, that's also a reference, right? So that'll also take you down to say here, right? That also take you down to this table down here, this page down here. Maybe that is where I find my 6. And then I can, take 6. Maybe I stored the value, then I can just give you the value, right? Or maybe this 6 will also lead me to the page where, its raw value is stored, right? And that's how B trees work, right? So you realize that I didn't have to search through the whole table, right? I didn't have to go through all these things, right? They were all discarded. All I had to do was to just, follow, some kind of references, some pointers till I get to my leaf page, and then I got the value for you. And that's how it works. Very efficient, super efficient. That's like the most popular indexing structure used in many databases now, right? The B trees indexing. Does this make sense? Does this make sense? Hello. Does it make sense?
Yes.
Yeah, good stuff, good stuff, good stuff. Okay, a lot of good stuff here, right? So, non-relational databases, equally do these cool stuff and so on and so forth. And I just want to mention one disadvantage. I'll say for non-relational, what do you call this, database like MongoDB, right? So here we talked about joining, right? It just occurred to me. Here we talked about joining, right? How for relational databases you take the two tables, right? Then you join them, then you get something this cool, right? Something this cool. But non-relational databases don't typically support joining, right? Joining is more of a relational thing, right? They don't support joining. So the system we are building now is users and their comments, right? Users and their comments, right? User can leave many comments. For a non-relational database like MongoDB, it will do something like this. It will create the user. It will be like user. This is how it will be stored in a non-relational database like a MongoDB. It will be like user ID. Let's say it is 2. Then the name is, let's say, A, right? Then comments, right? Then comments, right? To have a comments list here, right? Then it will maybe put the comments in here. So maybe the comments, maybe the body, or maybe let's say the message, let's just call it body, the body of the comments, right? Then maybe here inside here to have maybe another other object. So let's say, so here we have like the comment itself. So let's just call this message. Then maybe it should be like kill, right? Then maybe the comment author, right? Author ID. I mean, here you don't even, because it should be the same as 2, right? So you can just leave it there like this, right? So for that, you can do something like this. And because it's just one field, let's just put it as a string, right? I mean, we can just, okay, let's just keep this. Let's complicate our lives. Message, then P, right? then and so on and so forth, right? So let's say you have three comments. Let's say this is M, right? This is how MongoDB would store this thing, right? See, for relational database, they would break it down into two tables, right? Users and then their comments. And when they want to find the comments left by some user A, they'll just join the tables. Then they get something like this. Then they can just look through this table and then just give it to you. They can even group by. We'll do group by later. But for non-relational database like Mongo, right? When you have the comment for the user, it just appends. It has a comment field, so you can just append it to it for you, right? Very straight away, right? So you have to make the decision. Do I want to do something like this, right, or do I want to do something like this, right? Now the difference between these two things is that I realize that for the relational one, you can perform operations on the comments table, right? You can find, hey, what is the most popular comment? Hey, which user gave the most number of comments, right? Like you can you can treat the comments table as an entity, right? You can perform operations on its various records. But if I take this guy here, for instance, right, you can't just come and just find comments P, right? You can't be like, hey, which user has comment P? It's a lot of code, right? A lot of nesting, right? So if I design a system where you think you're going to, perform operations on the other table, like comments, like pictures, like posts, and those things, it's better you use the relational one, right? Because you're going to treat that thing as an entity, as a different entity. But if you're going to perform queries on these nested items, in Mongo, this is a very complicated thing, right? And it's very inefficient, right? You have to then use a loop, then loop through comments again, and so on and so forth. So that's something you should just keep in mind. Okay, I think we've actually done a lot on databases, and right now the assignment I'll give is please just brush over SQL. Like if you have these things we have discussed so far, like in your mind, I think it should be like very good for the most part. We literally explained login. There's actually something else you can do. Actually, let me talk about this too. We have some time. So there are so when you're designing systems, right, there are a couple of I don't want to really introduce like be mentioning things like designing systems, because I don't want people to think, well, we just need system design. We're actually doing software engineering and practice and everything, right? But I still have to mention it because it's essential, right? So we care about some things, right? Like if you use Facebook or WhatsApp or Instagram or even Zoom you're using, right? There's some things you care about. You care about availability, right? You care about scalability. I mean, you don't care about like they care, right? Scalability is, I'll explain them, no problem. We care about maintainability. We care about partition tolerance, fault tolerance. We care about all those things, tolerance, right? So let me just brush over some of those keywords very briefly, and then we also we just do overviews here, right? Because it's speed track thing, and so let me just talk about them and then on we go. So let's just call them non-functional. Sorry, my thing is. Sorry, my pencil is very interesting. So let's just call them non-functional. Right? Non-functional components of a system, right? Non-functional components. So the first one I want to talk about is simply scalability. I'm just defining them. Scalability. Scalability simply means, hey, with growing demand, can your system serve us, right? With growing demand, can it serve us? So hey, when I create some websites, right? 5 people are using it. Everything is so good. If 500 people begin to use it, can your system still serve all the 500 people? For now, these are things you don't think about as a user or as a client. I personally, years ago, I didn't think about this, and I thought that things happen magically, but things don't happen magically, right? Like your database needs to be scalable, right? Two, scalability is not just about the users using it. Sometimes it's about data. Hey, when I store more data, right, can it, can the system bear me? So look at the log thing we did, right? Look at the log thing we did. So we designed our own database right now, but it's going to be a log kind of thing, right? Like a text file, right? Where if new data comes, just append. If new data comes, just append, right? Someone will ask, what if I append, like, let's just write it here. What if I append like 20 gigabytes of data, right? But your hard disk is just 10 gigabytes, right? Can your system scale, right, to store this, right? And they're like, even for the 20 gigabytes, let's assume the past 10 gigabytes, I didn't need it, right? So can it scale, right? Can it scale? So that's something you should definitely keep in mind. That's called scalability. That with growing demand, can a system support everyone? Please keep these things in mind. They're very important. That's what scalability means. With growing demand, the growing demand can be data, can be users, can be requests, can be so on and so forth, right? The other thing we also care about is reliability and availability. Some people may add security and so on and so forth. Let me just add maintainability, tolerance, so on and so forth, right? So these are things that okay, let's go. So reliability is like, hey, just like English, is your system reliable, right? Is it reliable in the sense that the definition for reliability is a bit, people use this in different senses, in different forms, but it's more about how do I put it in more friendly terms? um um okay, let me just make it with tolerance, right? So wait, just a question in the chat. Let me just take a look at that. Oh, right. All right, yeah, exactly. Yeah, non-relational databases are more, not necessarily more scalable than relational ones. We can, you know what, let's apply this to database. I mean, that's the whole goal, to apply to database, right? So we understand what scalability means, right? Does everyone understand what scalability means, like at least at a higher level, that with growing demand, with growing, some stuff, can you still support, right? Can your database still support this, right? Now let's apply to database, right? So there are two ways to scale your system, right? We have vertical scaling. We have vertical scaling and horizontal scaling, right? And horizontal scaling. Now, vertical scaling simply implies take that resource you have. So let's assume it is one computer, right? Let's say it's one database. So think of it this way. Let's assume it's one database. So let's assume we use a file. This is just system, right? This is your database system, right? Right. Take that database and add more resources to it. So add more. So maybe enlarge the size of your disk, right? Now use 8 gigabytes, use 20 gigabytes, maybe use this number of this CPU, right? Use a bigger one or something, right? That's called vertical scalability, right? Kind of like take that one thing you have and increase its power, right? Increase the resources for it, right? So if it was first 5 gigabytes, hey, can you make it 20 gigabytes, right? That is vertical scalability, vertical scaling. Then horizontal scaling is like, that's fine. Take your 5 gigabytes, but buy buy 4 other 5 gigabytes, right? So vertical scalability just takes this one thing and then increases the result. So makes this one more big, right? Makes this one bigger, more gargantuan one. Horizontal one is like, hey, just take this one, but don't do anything to it, but add more, right? Add more like this, right? So that's how it works. Now, generally, this is known to be cheaper, right? Horizontal scalability is cheaper than this one, right? So relational databases, right? Relational ones typically do this. Relational ones do this. And non-relational ones typically do this. Non-relational ones. And there are reasons for that. We can go over some of the reasons why they do this, right? So look at the relational ones. They store the data in the form of tables, right? Tables. So the table is growing bigger, table is growing longer, table is growing longer, right? The moment you try to, split the table, right, like this, so that's like the first 100 items will be here, the next 100 will be here, the next 100 will be here, the next 100 will be here, right? So that is what is going to happen, right? Let's write it. So if I do assume I have a table, right, a relational database, and I have, let's say, 400 documents to store, 400 records, right? So I'm going to get 100, 100, right? Right, 100, right? It's going to be relatively difficult to actually, search through, right? Like, how will I know whether my data is here? How do I know whether it's here? How do I know whether it's here? How do I know whether it's here? It's a bit difficult. Even if I create an index, right? It's even more difficult if I have to perform joining, right? If I want to join, like if I want to join and the data is distributed across different database servers, it's very difficult, right? So, but look at non-relational database. It's just documents, right? Like, what is it? It's just documents, right? It's just like these documents, right? It's relatively like in joining, like you don't even perform joining typically on non-relational ones, right? So non-relational ones typically do horizontal scaling because it's way cheaper for them, and joins, they don't typically even concern with joins, right? Relational databases like this one, right? They like the data in that one system, right? On that one huge table. So that one, the table can grow big, and joining is way cheaper. Just take the data here from this database, data from this database, and then just join them together, right? So that is actually why that's why non-relational ones are generally considered like more scalable, right? Because and this is very cheap, right? This guy is very cheap. You can just buy some Quanchain computers, just convert them to your service, and it's very cheap. But this one, and you see this one too, you even get diminishing marginal returns, right? Like sometimes as you try to scale it vertically, at some point the yield isn't really as much, right? It begins to decrease, right? So that's something you should consider. So if you're designing a system, right, and the interviewer tells you, or you in the interviewer discuss the thing, and realize that, hey, am I going to perform joins? If I'm going to perform joins, right, like then, and I'm going to use a relational database, right? So let me reframe it. Am I going to perform joins? If you are not going to perform joins, right, and your data has kind of a fixed structure, right? What am I saying? Let me just write the thing down. Right, you're not going to no joins, right? No joins, right? And your data has a flexible structure, right? Or you don't even really care about structure, right? Just go with non-relational, right? Because it's very cheaper to scale. So it can be like, I can horizontally scale this, right? If you're going to perform joins, So like maybe users and their comments or stuff like that, and you're going to need to process the comments table. Then you're going to have to do vertical scaling, right, or stuff like that. So that is actually why non-relational are considered relatively cheaper because of and it's cheaper, right? You can just buy some cheap computers to the side and then just scale them horizontally. That's what we call horizontal scaling. Okay, now we want reliability. Reliability is like, hey, is your system reliable, right? And how do I know something is reliable? So, for instance, let's say you have a computer, right? I'm going to maybe blend tolerance in, right? Availability, think of availability as long-term reliability, right? I think that's one good way to think about it. So, reliability is like, hey, if I have a computer, right? What if part A of my computer, something happens to part A of my computer, right? It's my and I make a request to myself. Am I still going to get something? Am I still going to get something, right? Let's assume you have your database, right? And something happens to some part of your database. Is this still going to function, right? And if it's still going to function, that means that's high reliability, right? The computer is like very reliable. That hey, something may happen. There may be a fault, or there may be something. We discuss faults and failures later on. A fault is when something bad happens to your system, but it still functions, right? A failure is when the system stops functioning, right? So the system has failed, right? And faults can be human faults, they can be hardware faults, and so on and so forth. And availability is simply reliability over a long period of time. Is the system available, right? So for instance, and sometimes you have to prioritize one over the other, right? So if I take database again, if I'm browsing, let's assume you're on Instagram, right? On Instagram, and you know what, to sell those things later when we cap theorem, but yeah, and maintainability is, hey, is it easy to maintain your system, right? The database you're constructing, like, look at how complicated it is. If some new engineer comes in, can they easily fix it if something bad happens, right? Or stuff like that. And tolerance, we talk about tolerance later, how when one part of the system breaks, are the remaining parts able to still function, right? Do we care? There's something called fault tolerance. Those are things we also look at. So generally, this general overview of databases. Do well too. I know there's a lot you can actually go deep down. Like, trust me, you can go like super deep. But if you have generally like this whole idea in an interview or something like that, you should be able to make the decision what I need. I'm going to use a SQL. I'm going to need a NoSQL. I'm going to use this and this and this and this and this and this and that and that and that. God willing, next week we are going to narrow down on a few other topics. We're going to discuss caches. Should you just talk about caches right now? I thought you just talk about caches right now. Unless you can discuss something, because we have a few minutes, right? I mean, I've spoken fast, but I think we still have some time. See, let me just tell you what caches are. That you need to know them. Like, you need to see. There are some. When I was having a discussion with a friend of mine, I think it was 2 weeks ago or something. We're like, hey, if you have a system design question, 2 things should come to your mind. Load balancer. Every day, just use, I'm going to load balance everything. We discuss all those things like next week. So let's just talk about caching. It's very simple. Caching is super simple, trust me. And then we can go ahead. It can be detailed, but just going to do the simple version, right? So let's assume you're the client, right? You're here. Your database is here. We're on databases. This is your database. Very cool stuff. Database here. And this is you, right? And then right now, you asked for data, right? Where you're still using the name and the phone number thing. So your name, you gave the name, no better name than Cornelius, and then you just want the phone number, right? Phone number. So okay, let's see, you have that, and let's have this. Sorry, my thing. Okay, so you made a request where you're like, hey, I want the name, right? I want the name. So this is your request, right? And this is a request body. This is what you call the request body, right? Just want the name, right? And just want the phone number, right? So just made a request, right? Then it comes here, it gets from the database, it's like, ta-da, the phone number is 666. And then it gets the number, and then, wait, that's a bad number, 667. Okay, so it gets the phone number, then it brings it back to you, right? Then later, you make that same request, right? It doesn't have to go back to the database again, right? That's a lot of travel, right? Assuming it's even using indexing, it's going to do the same thing once again, right? That's a lot of work, right? So what we do is that each time you fetch some new data, what we do is that we cache the data. We store it in it can be an in-memory structure here. So this is what we call our cache, right? That's like, so we're just going to store Cornelius here. You store the phone number here, 667. So the next time I make the request that I want Cornelius, all it does is that it first comes to check my cache first, right? So it doesn't go straight to the database anymore. So we no longer go straight to the database. Instead, what we do is that we first go to our cache. We're like, hey, are you in the cache? If you're in the cache, we call it a cache hit. A cache hit. If you're not in the cache, what we do is that we call it a cache miss. So if I miss, right, if I miss, what was I saying? If I miss it, I come to my database, then I fetch it, right? Now, if I fetch it, let's clean this now. So now this is how my path looks like, right? So if I first come to my cache, if I hit it, I'm done. I'll come back here, right? Then I'll bring it here. That was very fast, right? Cache is so fast. Cache is very, in fact, cache, we have levels of cache. We have the L1 cache, L2 cache, L3 cache, and so on. Right? Caches are so fast. From cache, then you go to other. I'll show you the memory hierarchy actually. So cache is very fast. I didn't even have to go to database. So I didn't get my data very fast. So those of you who have been building websites, sometimes realize that if you build, like say, a website, the first time you load it, it's a bit slow, right? Some page or some images, right? The first time is slow, but you load it again and now it's faster, right? Because the first time you loaded it, it actually got cached somewhere in memory or something, right? Your browser will cache it. Then the next time you try to do it, it doesn't go back to the database or to the server, right? It just gets from the cache and gives it back to you. That's what we call caching. So when I make the cache miss, I'll then come to my server, right? My database, and I get the data, then I come and put it in my cache now, right? I now come to my cache, I come and put it in my cache now. I'll store it here, and then from here I can then bring it back to you, right? That is how basically caches work. So I make the request, I come to my cache. If it's in the cache, hooray, I'm done. I just come back here, right? If it's not in, what do? I just come here, get it from my database, I'll store it in my cache, and then I'll take from the cache and I'll bring it back to you here, and then I'm done, right? There's a lot more to it, right? If I want to write data, right? So something you can see is that sometimes, right, you have the data here. I think we should go more into cache call next week, right? Because look, it's possible that you loaded the data, right? Like you took the data. Let's say Cornelius' number has changed, right? Let's assume now it has changed, right? If it has changed, I have to come and write new data here. So let's say now the number is 778, right? But then in your cache it's 667. So if I make the request for Cornelius again and I go back to the cache, there's still Cornelius here, right? 667, but that is wrong. You know the answer is 778, right? So it's inconsistency, right? So there are ways to handle this thing. We have so that leads us to types of cache. How will you call them? Protocols? I don't even know. You have the write through, and you have the write back. Write back. So what write through will do is that for write through, if I want to write the new number 778, what it does is that it will first come and write it to my cache here, 778, then to go and write it to the database to 778. That's how write through works. For write back, what it does is that it will come and write to the cache, but it's not going to write to disk for now. To write to disk later on in future, right? For instance, if I have to remove, maybe I have to empty my cache for some new data. Don't worry, we go over caches, small God willing, next week, but just want you to have the main idea that hey, just use to store data that was recently accessed, and then later in future, if I want to access the data, I just go to the cache, get that data, then bring it back to you instead of going to server. There are many ways, there are many other things that electricity said with caches. In an interview, maybe I don't know. Usually they just want you to just be like, hey, so I'll use a cache here, and nobody's going to ask you to explain the details of a cache. I don't know, that's a bit different. I've not seen something like that before. But just know we're going to use a cache, right? Just know what a cache does. Just know the cache does this. We have different types of caches. There's something called CDNs. All right, I like talking a lot. We'll go over these things next week, but overall, I think we have a very good overview of databases and so on and so forth. Let me just show you a resource you can use, especially those of you who are in interview stages and those of you who want to learn more. So let me share my screen from this part. I just want to show you a book, something else you can also use. Also, one thing I've been saying is that much of the software engineering stuff we do is actually a lot of self-learning, right? Like me personally, like some of these things I'm even telling people, I actually had to like I wasn't like taught in class or anything. I literally had to read books, right, to self-learn them. So can everyone see my screen? Can people see my screen?
Yes.
Okay, good stuff, right? So this is a book. I just shared it in the group. So this a book. This was the first book I read on system design. And how this book works is it gives you a general overview of system design, right? So the first part is it just tells you if you have an interview, definitely read this part, right? It tells you if you have a system design interview, this is how you should approach the question, you clarify it, this and this and this and that. Then it starts with example, like questions, right? And the solutions. So this is like design a tiny URL system, right? But I would say don't go, you can read maybe that for the tiny URL one. Then when you're done, stop, right? Scroll down and go to I don't know what that blue thing is doing there. I don't know where it comes from. This bro, sorry. How do we get here? Okay. So then go here, scroll down. This part down here is teaching you the concepts, right? This part down here gives you a concept. Yeah. Oh no, sorry. The part down here is going to teach you the concept of like some concepts you need to know, right? I don't know why they made the book that way. Or maybe because I downloaded it from online. Sorry, give me a second. Let me just scroll down. Okay, it's system design something something. Ranking. No. Where is it? Ugh, bro. Give me a second. Oh, right. We are here. Good. So when I maybe done going through that first problem, right? On design, what do you call it? Tiny URL. Just come in and learn the basics. These basics are so important, right? Like they'll teach you the things, right? What does scalability mean, right? So you learn like even if you want when you take this book, come and learn the basics first. Try to understand the basics first. Like please read the basics. You tell you what scalability means, right? See, even the things I'm in vertical scaling and horizontal scaling, right? What they mean, reliability, right? The problem is availability. It will teach you all those things. So load balancing, that's something to talk about next week, right? And to teach you, so learn the basics. Don't start solving the problems. If you want, just read the first problem just with curiosity. See, there's even caching here, right? Like what caching does. I even mentioned the CDN and cache invalidation, right? So definitely, read this. Read the basics to understand. Some of them won't make sense to you if it's new to you, but that's fine. Ask ChatGPT. Hey, what else? If I show you what do you call it? Like sometimes I'm actually reading a certain book on like right. I was reading a certain book and I saw something. What was it? Tail latency amplification, right? And I didn't know it, right? The book, the book said something, but I didn't really get it. I came to here and I just came to ask this guy, hey, what does this mean? So if you're reading the book and it gets stuck somewhere, it's simple. Just watch YouTube video, go to ChatGPT, have a discussion with it, right? And so read this book. And when you're done, and then come up here and try to solve. And when you're reading the book, make highlights, write in the book. You have to print it out, print the notes out, and then read. Then there's another book. This is the number one book I'll recommend. There's another book. If you think you have funny interview, just read this book. And just read this book. There's actually another website too you can just explore. System Design Primer. Okay. So this one, I don't think you have much time to do this, but if you do, definitely explore this guy too. I didn't do this. Honestly, I'll just say read the book. If you read the book and there's a concept you don't understand, just go online and just watch it, right? Maybe you can come here then be like, what does this mean or something like that. And when you are done, just if you have an interview, if you have a system design interview, please go to YouTube and then go to this guy. You just do the system design interview and then watch. What's this? And then watch a live system design interview by someone. This guy here, he's so smart. This is a how a typical system design interview is done, right?
Yep. Mark.
He's called Mark.
So
right?
we've got he
walks you through it, right? So he's designing
simple metric.
He's designing TikTok, right? TikTok system, right? He shows you how to narrow down the problem, how you scope it down, scope it down, and so on and so forth. Well, I had an interview like 2 weeks ago or something. I just watched one of his recordings and it was super helpful. And I applied it. So you read the book, you understand these are non-functional components, scalability, reliability, and those things we mentioned.
So if you do
right
in that ways.
And yeah, so that's about it. And the last book, I don't think you need to what's the last book? Where's my book? Data intensive web applications. This is another book I'm reading currently. It's actually a very good book. I actually learned a lot from this book. The author is really good. He's called Clipman. He's a very good guy. If you want to learn more about database, want to learn deeper about some systems and stuff. But there are things you can read after you get your offer, you're home, you're bored and stuff. You're like, hey, let me read this. See, even the things we walk through with B-trees, right? You can see B-trees. You want to find, let's use this. You want to find the user with ID 251, right? You want to find let's say the contact of a user with ID 251, right? So you come here, this is your root table, right? They're like 251. This is 100. This is 200. This is 300. Now 251 should be in the middle here, but that's a reference. So you follow it down here. And this is 250, right? You follow it down here. This is 210, 230, 250, 270. That means 251 should be somewhere in the middle here. So follow the reference down here, right? Then you follow down to this page, and then you see, tada, here you find it on the leaf node, right? Very cool stuff. Lots of cool stuff in the world. And there's a lot more. I read this some time ago too. So that's about it for today. Oh, the book. Oh, Chardon is actually what do you call it? Chardon is typically if you scale horizontally, right? Chardon is like splits the thing, creates shards of it, right? Yeah. The book. So the book. I've put the book in the Slack workspace actually, so you can check the Slack workspace. I mean, I've put the first book I showed you there, so you can just skim that book. And yeah, for the other one, the data intensive one, you can just read it later. It's a cool stuff book to know, but I think you don't really have to go through it now. It's a lot of stuff too, but I don't think you have time. I mean, if you do, you can just ask me. I can give you the book too. But yeah, okay. That's about it for today. We've gone through a lot. Go next week. We're going to talk about caching in details, talk about load balancers, talk about maybe message queues, and maybe content delivery networks. And then we should hop on to the next thing, and we should be good for the most part. If you have an interview upcoming, please read the system design basics in the textbook I showed you, then watch somebody's mock interview on YouTube. We can also mock definitely. I've not done as many system design interviews. I've done quite a couple. But I think I can still give something, and then on we go. All right. Thank you people for attending. I hope this meeting was recorded, and we will upload and then share it. All right. See you all later. Bye.
Bye.